Okay, so let's go over some of the examples at the bottom of the page. I'm not going to do all of them. I just want to do maybe 4, and then we're going to work some in class tomorrow. And make sure and make a note things you don't understand. So on 13, you have x to the 1/5 times x to the 7/5. Okay, so all of the properties of exponents, all of the properties of fractions apply to these rational exponents. So when you have a base times a base, you add the exponents together. So I'm going to add the 1/5 plus 7/5. And anytime you are adding fractions, the denominators need to be the same. So what that means is, since these denominators are the same, I'm going to add the numerators. So I get x to the 8/5. So that was nice. I didn't have to find a common denominator. And I have an improper fraction. So you really do want to go ahead and simplify when you have an improper fraction. 5 will go into 8 one time, so you have an x that you can take out, but you have 3 left over, so that's going to stay as a, in parentheses with a rational exponent, and that would be your answer. So if you were to write it in radical form, you would have x and then the 5th root of x to the 3rd. Now the thing is, if they present the problem to you as a rational exponent, then your answer needs to be in the same form. So you would want to use this as your answer and not the radical. If they give you a radical in your problem, then you want to write your final answer in radical form. Okay, so let's look at number 14. Y to the negative 3/4 power. Now, it's okay to switch back and forth as you're working these problems out. It's just that in the end, the final answer, you want to write it in the same form that they gave it to you in. Okay, so in this one, I have a negative exponent, which means I need to move the base to the other side of the fraction bar. And right now, this y is over 1. It's a whole number. So to make my exponent positive, I'm going to move the y to the denominator, and once I move it to the other side of the fraction bar, the exponent is positive. So you can't forget to change your exponent to positive when you move it across the fraction bar. It'll mess you up. Okay, so if you were to write this in radical form, it would look like this. 1 over the 4th root of y to the 3rd. The numerator is your exponent. The denominator is the root. So my index is 4. I need 4 of the same factors to get rid of the radical. And I can't keep the radical in the denominator. I have to rationalize it. Okay, so this 3 tells me that I have 3 factors of y right now. So I need one more factor of y so I can get rid of that root in the denominator. So I'm going to multiply top and bottom by one more factor of y. Oops. Okay, so now I have 4 factors of y in the bottom when I multiply them together. So I can get rid of the root in the denominator, it's just y. And in the numerator, I'm going to have the 4th root of y. Okay, so as a rational exponent, I want this fraction to be equal to 1. So I want it to be 4/4. It needs to match the denominator. The numerator needs to match the denominator for it to equal 1. Right now, I'm 1 short of the numerator matching the denominator. So with rational exponents, I want to multiply one more factor in the 4th root of y, top and bottom. So you're doing the same thing. I just want to show you both ways what it looks like. So now I have base times base. I'm adding my exponents together. 3/4 times 1/4 is 4/4, which is 1. So I have y to the first power in the denominator. 1 times y to the 1/4 is just going to be y to the 1/4. So you would have your answer in rational form. And if you were to work it using radicals and then you need to change it back to rational form, your exponent here is just a 1. So y to the 1/4 and then y in the denominator. You're going to wind up with the same answer either way you do it. Okay, so let's move on to another problem, and then we will do some of these tomorrow in class, so you'll have a chance to ask questions as we're working some of these out. Okay, so 17, the 8th root of 81 over the 6th root of 3. So the first thing you want to do whenever you have a composite number, anytime you have a composite number, you want to think, I need to rewrite this prime number raised to a base. That's the first thing that needs to come to mind. So for 81, I'm going to just do a little factor tree over here. 81 is 9 times 9, and I know that 9 is 3 times 3, so my prime factors for 81 is 3 times 3 times 3 times 3, 3 to the 4th power. So I'm going to rewrite that prime number raised to a power in my root. Okay, so my next step, now I can't really work this problem leaving it in radical form. I need to change it to rational form for my exponents in order to do anything to manipulate this at all. So what I'm going to do is I'm going to write them both with rational exponents. So the numerator is going to be 3 to the 4 over 8. The denominator is 3 to the 1 over 6. Now the numerator exponent I can simplify. So they both have a factor of 4, so that's going to be 3 to the 1/2 over 3 to the 1/6. Now when I have the same bases dividing each other, the rule is to subtract their exponents. So instead of trying to rationalize and everything, let's simplify this by subtracting the exponents. So I have my base. I write down the numerator exponent first, minus the denominator exponent. Okay, now in this case, I need to have the same denominator to combine my fractions. The common denominator is 3, so I'm going to work that out just down here at the bottom. Okay, 1/2 minus 1 over 6. So in order to get a common denominator, I need to multiply that 1/2 by 3 over 3. So now I have 3 over 6 minus 1 over 6. And when I subtract, I get 2 over 6, which reduces to 1/3. So my rational exponent, after I subtract them and reduce them, is a positive 1/3. And it makes a difference if it's positive or negative, right? This one's positive, so that means that I don't have any radicals in the denominator. My answer is just going to be 3 to the 1/3 power. Okay, your original problem was in radical form, so I'm going to rewrite this in radical form. I've got the cube root of 3, and that would be your final answer. Okay, now we do have a few more problems to do, 18, 19, and 20, but I'm going to just save those until tomorrow. Let's do some more examples in class, and we will have an assignment to work on. Okay, so have a good night. We'll see you tomorrow.